All right, so we're gonna start off section 2.1 or module 2 as they call it in your book, section 1. But we're gonna take 4 days kind of breaking this down, maybe 3.5, we'll see. But about 4 days is what I'm kind of spreading this out into. They're gonna be smaller lessons with a little bit of homework given. Maybe I give you some extra practice later on after we're done with the lesson, because we are gonna have like a homework day to make sure you guys get your homework done, but maybe to get you like some extra practice kind of to do it in class. But we'll kind of talk about that as the time comes. But for today, we're doing polynomial functions. This is 3 days for sure of polynomial functions. Okay. Now, the thing we're going to focus on is called end behaviors. Okay. End behaviors. So the end behavior of a polynomial function. So end behavior of a polynomial function. If you're wondering what the heck does that mean, what it basically is, and right now I'm going to erase this, but it's basically this. If a function does this, I can say that on the left side, see where the arrow is on the left side of this graph? It's going like towards negative infinity on the x, meaning it's going left forever, and it's going up forever, right? This side right here, this left side is going up and to the left forever, okay? And then if I say, well, what's happening towards the right side of it? Well, towards the right side, it's growing down and to the right forever, right? It's moving two different ways. So as sometimes some books say, as it goes towards positive infinity, right? As it goes to the right, that's what that means. It's going towards negative infinity, meaning down. But I try not to do it that way. I'm not a big fan of that. I prefer saying like it's going to the left and up, or to the right and down, like that. It's a little easier to kind of understand that. So how can we tell end behavior? Because there's going to be characteristics that you can look at your function. So here we go. Given a function y equals ax to the n plus, now this is going to look really, really weird, but just bear with me, okay? Bx to the n minus 1 plus cx to the n minus 2 plus etc. In other words, I'm going to give you a polynomial function, okay? It can be like 2x squared plus 3x minus 1. It can be 4x cubed minus 5x. It could be anything, okay? This is just saying I'm going to give you a function. It's going to have a number in the front. It's going to have a power, okay? It's going to have all these little parts to it. We're just going to focus, us personally, on the ax to the n. This is going to be the most important part for us, okay? So if n is even, so let me highlight this just so I can kind of give you some direction, okay? So you guys remember how ax to the n, the very first term, they call it the leading coefficient and the leading variable, right? Like the degree, as they would call it. So for us, the degree is the letter n, the highest power, okay? If n is even, so in other words, if you had a function that said like x squared, x to the fourth, x to the sixth, x to the eighth, x to the 10th, if n is even, okay? So there's going to be one situation, there's two situations. So if n is even, and, actually I should have put this right here, and dot, 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 let me extend this little line here. So if n is even and a, excuse me, a is negative, So your leading coefficient, if your leading coefficient is negative, in other words, if I wrote like y equals negative 3x squared, so even power, negative number in the front, negative 3x squared. What happens in that case? So if a is negative, but the power is positive, so we're going to say it goes up to the left, it goes up to the right. Now, how can I show this to you? Well, there's the function x squared. You guys know it, right? If it's a negative x squared, it looks like this. Or we can even say like negative 2x squared will look like that. Notice how it goes, not up, down. I messed up. It should be down. My apologies. Let me move this real quick a little bit to the right. It's supposed to say down. My head was thinking the right thing. My hand did not write the right thing. So there's one quick example. Another one we can do like a fourth degree. So a fourth degree might look something like this. Let's say negative 3x to the fourth. So notice both of these have even powers, but with a negative coefficient in the front, a negative 2, a negative 3, right? They go down and down, down to the left, down to the right. Okay? So if a is negative, it goes down. Okay? Now, what if a is positive? If a is positive, then these go up. Okay, sorry about that. So it goes up to the left, it goes up to the right. So in this case, here's like a half x squared. Look kind of like that. Even power, positive number in front, a half. Notice how it goes up and up, right? Up to the left, up to the right. It rises to the left, it rises to the right, however you want to say it. Okay? If you had an x to the fourth function, it might look something like this. Like this right here is like y equal to just x to the fourth. In front of the x, there's a 1. We don't see it, but it's a positive 1. So it would look something like that. Okay? So what we're doing today is we're just describing what the graph does on one end and the other end. I don't care what it does in the middle. Who cares? I don't care about this part right here that I'm about to circle. Who cares about that part? All I care about are the end points. What are the end points doing? Up to the left, up to the right. Maybe down to the left, down to the right. You might say, well, that's kind of easy because they both do the same thing. Yes, even powers, the even degree, if the highest power is an even number, they either both go up on both sides or they both go down on both sides, okay? The odd powers do something different. So here's the other situation. Remember I told you there's two situations? Here's the other one. If n is odd and so if n is odd, I should highlight my a value just so we have that. So I'll highlight a just so you guys know. So this one says, what happens if my highest power is like a power of 3, a power of 5, a power of 7, even a power of 1, but we don't normally do the 1. But a 3, 5, 7, 9, 11, 13, 15, etc. Odd leading power. The degree is an odd power. So if n is odd and A is negative. So if my A term is negative, okay, then it goes up to the left, it goes down to the right. So an example of this will look like this. This is y equal to negative x cubed. So notice it has an odd power of 3, and the coefficient in front of it is a negative 1. So if it has a negative number in front of it, okay, and an odd power, then it's going to have this behavior. Notice as it goes to the left, it goes up. So it goes up to the left. It goes down and to the right. So as it's going to the right side, it's going downwards. Okay? So if A is negative, it goes up to the left, it goes down to the right. Now, if A is positive, it's basically just going to reverse the options. So A is positive. So again, this is my A term here. So it goes down to the left, it goes up to the right. So I mean, I can use the cubic function again. This would be more like y equals to 2x cubed, or maybe a half x cubed. Notice the power is still odd, okay? And the coefficient in front is positive, okay? So it goes down to the left, it goes up to the right. This is what you guys have to try to memorize, okay? Or if we start using notes, you're going to want to put this on your notes. That way, if I tell you, what is this graph doing? If I ask you, what is this graph doing right here? What's its end behavior? You should be able to tell me. Highest power is a 4, so it's even. So look at your list. Even power. And it's positive in front of it. So they both do the same thing. They either both go up, up, or down, down. Which one is it? If it's a positive 5 in the front. They both go up, up. Right? So you're going to say up to the left and up to the right. That's it. Like, that's all you have to say. Okay? So this graph right here, a solution you would say was that it goes up to the left and up to the right. That's it. You don't have to do anything else. You just have to describe what happens on the left side and on the right side. Is it going up or is it going down on the left? Is it going up or down on the right? Okay. So what if I give you this example here? So example number 1, I'm going to put describe the end behavior. We'll do like 3 of them and then we'll be done. Okay, so we're going to describe the end behavior. None of these are coming from your homework because these are too easy. Okay, I don't want to do your homework for you. You only have 4 problems of these things. They're not hard. You just got to look to see what are they giving you. Look at your chart and or your written notes and say, okay, it falls under this one. Okay, so here we go. What if they give you one that looks like this? They say, okay, f of x is equal to negative 3x to the 5th minus 6x squared plus 7. And I want you to tell me what happens on the left side and on the right side. So all you have to do is look for the highest power. Sometimes it's not in the very front, okay? Sometimes the highest power is in the very back. So look for the highest power. The highest power is a 5. That makes it odd. Okay? Now, the number in front of this highest power is negative. So what does that list that I gave you tell you if it's odd with the negative a term? What's happening to the left side? It's going up or down? Some of you guys are going like this, up, right? What about to the right side? Down. So left is up, down to the right. So I'm going to put goes up to the left. It goes down to the right. That's it. That's all you have to do. Okay. Now, sometimes they are going to give it to you looking a little different. Maybe they're going to put like negative 6x to the fourth, and that's all they're going to write. They didn't even put y equals 2. They didn't put f of x. They just put that. So in this case, you're going to look at negative 6x to the fourth. I mean, there's only one term. So the power is a 4. That makes it even, right? And the number in front is negative. So what's it doing on the left and the right side? It's going down, right? So I'm going to put goes down to the left, goes down to the right. All right, now I'm going to give you a tricky one, and then after that, we're done. Now, I say tricky, but it really isn't. Just pay close attention. Oops, not y. I'm sorry. So again, I want you to tell me which way it goes. So write it down, okay? Write it down. Look at the list of stuff you wrote. Figure out what the degree is. Is it even or odd? What about the number in front of it? Positive or negative? Based on that, it should fall into a specific category. Okay? And then once you have that down, you should write down what it does. Okay? Anybody want to tell me what you got? Anybody interested? Brave enough? No? So, odd power. So that means they go in different directions, right? Odd powers, different directions. With the positive 14 as the number in front of it. So it's a positive with an odd. That means the graph is going down to the left, up towards the right. So this goes down to the left, goes up to the right. Oops, I forgot to put the there. Hold on. To the left, up to the right. And that's all.